Hello, welcome to our last lesson in Unit 3A. This is going to be Lesson 3A-10, the quadratic formula. Our learning target is going to be that I can solve quadratic equations using the quadratic formula. So we've used a couple different methods of solving quadratic equations so far. We've talked about completing the square and we've completed about solving by factoring. Now, each of those can be very useful, but there are times where we have a quadratic equation that's not quite necessarily the easiest thing to factor or to complete a square on. And for those type of problems, we're going to use the quadratic formula. So first, let's fill in our last vocabulary word for this packet, and that is going to be standard form of a quadratic function. And the standard form of our quadratic function is just going to be ax squared plus bx plus c. And if you want to add, you can add it where a is not equal to 0, because if a was equal to 0, then it would not be a quadratic, it would just be a linear function. But make sure you go ahead and have at least in your notes it is ax squared plus bx plus c. So we've learned, like I said, several methods for solving quadratic equations. We're going to show you this one last method, and we can use this method on any quadratic equation as long as we write it in standard form. So we've been limited before on some things that don't factor, but the quadratic is going to give us a tool that's going to let us use it for any quadratic. Now, when we say standard form of a quadratic, that's what we talked about in our vocabulary. That is ax squared plus bx plus c equals 0. As long as we put it in that form, then we can use the quadratic. Alright, we do have a proof of the quadratic formula. By completing the square on the standard form of the quadratic equation, we can actually derive the quadratic formula ourselves. Now, I'm going to go ahead and do that in a separate video. To see the proof of the quadratic formula, because it would be a little bit of a long video if we tried to do everything together, please click on the link on this video. It's going to pop up right here on the screen that you guys are watching right now. You should be able to click it and it'll take you straight to the video for the proof. Yes, we do want you to watch this. It is required for you to watch it and add to your notes. So go ahead and click on the link now. That way you can go ahead and watch that video and then come back here when you're done. You can go ahead and pause this video now, and when you're done with the proof of the quadratic formula, we'll go on with this lesson. So go ahead and pause it and click on the video now. Seriously, go watch the other video before we go on. We'll be right here when you get back. If you haven't done so yet, go ahead and pause the video, go watch the other video, get the proof of the quadratic formula, then come back and we'll move on. Alright, so you could see in our proof that when we derive the quadratic formula, it is going to look like this. X is going to equal negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Now that is a little bit to remember. It is on your formula sheet, so go ahead and make use of that. Remember, we have these taped to your mastery check stations and distributed throughout the classroom on the different tables, so make sure that you are making frequent use of it. But we are going to use this formula to help us solve some quadratics. So looking at example 1, we are given a problem where we are told to find the 0 of x squared plus 9x minus 14 equals 0. So when we are solving by using the quadratic formula, we're going to follow 4 steps. The first thing we're going to do is write the equation in standard form. That is ax squared plus bx plus c equals 0. Alright, the next thing we're going to have to do is determine the values for a, b, and c. And we want to plug these numbers into the quadratic formula. And then we want to simplify. So looking at example 1, we are already in the standard form. We have everything equal to 0. If we look at our values, a is going to be 1. It would be this 1 right here in front of the x squared. Remember, if there is no number in front of the variable, our coefficient is 1. Our b is going to be 9. And our c is going to be negative 14. Alright, just a reminder of our quadratic formula. It is negative b plus or minus the square root of b squared minus 4ac over 2a. And this is again on your formula sheet for you to refer back to. So next thing we're going to do is plug these numbers into the quadratic formula. So a negative b is going to give us negative 9 plus or minus the square root of b squared, which would be 9 squared, minus 4 times a times c, and c was negative 14. So let me go ahead and plug that in. All over 2a, which a was 1. So now we want to go ahead and simplify. I'm going to have a negative 9 still, plus or minus the square root. 9 squared is 81. And if we type negative 4 times 1 times negative 14 into our calculator, we're going to get a plus 56. Be careful with these when you're multiplying, that you make sure you pay attention to all your signs. A little hint, if you have just the one negative, you're going to come out with a negative number here. If you have two negatives like we have here, it will come out positive. And if all three numbers are negative, you will come out with a negative as well. Alright, so over, we can go ahead and simplify 2 times 1 is 2. So we're going to simplify this further. Negative 9 plus or minus the square root of 81 plus 56 is going to give us 137. And all divided by 2. Now, we are at a point where we need to check to see if we can go any further in simplifying. Now, we would want to look at our radical, and if our radical can simplify, we'll want to use those strategies that we used in lesson 1-13, going back to the very first unit, and simplify that. See if we have any pairs that we can move to the outside or anything like that. In this case, 137 is not going to be able to simplify. So we are actually going to leave our answer as negative 9 plus or minus the square root of 137 all over 2. Now when you're doing an application problem, as you'll see when Ms. Blaylock does the application video, we will go ahead and take this to a decimal. But when we are just solving these naked problems, as you will, problems that have no context or anything like that, then we're just going to go ahead and leave this in the simplified form with the radical right here. Alright, so let's go ahead on to example 2. Now if you notice in example 2, we are not quite in standard form yet. So to be able to be in standard form, we're going to have to move that negative 4 to the other side. And to do that, we have to add 4 to both sides. So that's going to give us negative x squared plus 3x plus 4 equals 0. And now we can go ahead and plug into our quadratic formula. So if we are plugging in, our a this time will be negative 1 since we have that negative there. Our b will be 3. And our c will be a positive 4 since we moved that to the other side. So when we plug this in, we're going to have a negative b, or negative 3, plus or minus the square root of b squared, which was 3, minus 4 times a, negative 1, times c, positive 4, all over 2 times negative 1. So we are going to do negative 3 plus or minus the square root. 3 squared is 9. And negative 4 times a negative 1 times a positive 4 is going to be a positive 16 over 2 times negative 1. So we will have negative 3 plus or minus the square root of 25 over negative 2 if we go ahead and multiply that out. Now 25 is a perfect square that we can simplify. So this is going to break down into two problems now. This is going to split off, and we're going to have negative 3 plus 5, since 5 is the square root of 25, over negative 2. And we're also going to have negative 3 minus 5 over negative 2. So negative 3 and a positive 5 is going to be a positive 2 over negative 2, which is going to give us negative 1. And a negative 3 minus 5 is going to be a negative 8 divided by negative 2, which is going to give us a positive 4. So in this case, x would equal negative 1 and positive 4. Alright, so how many solutions does a quadratic have? Although so far with what we've been doing with factoring and completing the square, we've always been expecting 2 solutions from every quadratic formula, where we get the plus or minus from taking the square root. However, there are scenarios where this is not the case, and it is possible for a quadratic equation to have only one solution or even no solutions. And the part that's going to give this away for us is the part where we're looking at the what we call discriminant. And the discriminant is the b squared minus 4ac. And that will give us an indication of what we are going to have. So if we have 2 solutions, I'm going to draw over the smiley face here, b squared minus 4ac will be positive. That means we're going to have 2 solutions. Alright? For one solution, b squared minus 4ac will be 0. Anytime we get 0 underneath there, we're going to have just one solution. And finally, if b squared minus 4ac is going to be negative, that means we are going to have no solutions. And the reason because of that is because that we cannot take the square root of a negative number and get a real solution. That is not something that we can do yet. That's beyond our scope. In later algebra classes, you will get into the imaginary number plane, and you will be able to take square roots of negative numbers. But in this case, we're going to be able to say that there are no real solutions because, as you can see, this graph would never touch the x-axis. So we'll look at 2 more examples and then we'll turn you loose. Alright, so let's go ahead and look at example 3. We are given 2x squared minus 12x equals negative 18. The first thing we are going to have to do is move everything to the same side and put it in standard form. So we would have 2x squared minus 12x plus 18 is equal to 0. Now we want to go ahead and identify our a, our b, and our c. I'm just going to do that up here where I have some space. A is going to be equal to 2, b is going to be equal to negative 12, and c is going to be equal to 18. So the next thing I'm going to need to do is plug this into my formula. So I'm going to have a negative b. In this case, b is negative. So a negative b would be a positive 12 plus or minus the square root of b squared. So that would be negative 12 squared minus 4 times a, which would be 2, times c, which would be 18, over 2a, which is 2 times 2. We are going to simplify. We're going to get 12 plus or minus the square root. A negative 12 times a negative 12 is a positive 144. And a negative 4 times 2 times 18 is going to be a negative 144 over 4. So I'm going to simplify this, and I'm going to get 12 plus or minus the square root of 0 over 4. Now if we remember what we were just talking about 2 solutions, 1 solution, and no solutions, we should expect this, since it has a 0 in the discriminant, the b squared minus 4ac. I'm just going to make a note of that one more time over here. Discriminant, which is the b squared minus 4ac. Alright, that is going to be 0. Now when you take the square root of 0, you're going to get 0, and 0 is neither positive nor negative, so we can just do 12 plus 0 over 4, which is going to, of course, be 12 over 4, which will be 3. So we can see that we end up with just the one solution instead of 2 solutions. So this would be a graph where it comes down and it touches the x-axis in exactly one place and does not cross at multiple points like the previous 2 problems. Alright, let's look at one last example. So we are given x squared minus 6x plus 11 equals 0. This is already in standard form, so we are good to go. A is going to be equal to 1, B will be equal to negative 6, and C will be equal to 11. So we are going to plug into our formula a negative B, so a negative 6 would be a positive 6, plus or minus the square root of a negative 6 squared, B squared, minus 4 times A was 1 and C was 11, over 2A, which would be 2 times 1. We're going to have 6 plus or minus the square root. A negative 6 squared is a 36, minus 4 times 1 times 11 is 44, all over 2. So we're going to have 6 plus or minus the square root of a negative 8 over 2. And now if you type that into your calculator, square root of negative 8, we're going to find that we are going to have some errors. So we are actually not going to be able to go any further with this. We're going to have a discriminant that is negative. So what we would say here, since we have a negative under the radical, is that we have no real solutions. We do have some imaginary and complex solutions, but like we said, we're not going to talk about that in this course, so we are for now just going to leave it as no real solutions. Alright, that wraps up our final lesson for Unit 3A. Please make sure you pick up the application 3A-10 from the Algebra Embassy. The application video can be found directly below this video to help you out on that. Alright, once you finish the application and your practice, go ahead and take the mastery check, and then make sure you grab a study guide to prepare for the 3A test. Good luck! See you in the next unit.